Today, we're going to crack open a Python tool that lets your code react to the world in real time. We're talking about the while loop. So think about this. With a for loop, which you're probably used to, you can tell Python, hey, do this exactly 10 times. Easy. But what if you don't know the number? What if your program needs to just wait, to listen and keep checking until something specific happens, like a user finally typing quit or maybe a game character's health hitting 0? Well, that's the exact problem the while loop was made to solve. You see, in Python, you've really got two main ways to make a loop, and it all boils down to one simple question. Are you counting, or are you checking a condition? On one hand, you have the for loop. That's our trusty counter. It's perfect for when you're going through a list, or you just know you need to run some code a fixed number of times. But on the other hand, you have the while loop. This one's different. It's not about counting at all. It's more like a security guard, constantly asking a question. Is this condition still true? And as long as the answer is yes, it just keeps on going. You know, to make this idea really stick, let's step away from the code for a second and think about a little device that's in pretty much every home. This single sentence, this is the entire logic right here. A smoke detector is a perfect real-world while loop. Its main job is to do one action, which is to silently monitor the air while a certain condition is true. And what's that condition? That the air is clear. And that's the trigger. The very second it detects a puff of smoke, that no smoke condition becomes false. The loop of silent checking doesn't just finish up. It stops dead in its tracks. It breaks, and a totally different action starts, sounding that loud alarm. That, right there, is the heart and soul of how a while loop works. Okay, so we've got the analogy down. Let's see how this really elegant logic translates from a smoke detector into actual working Python code. All right, take a look at this. We've got a simple little program that simulates a phone's battery. The whole point is to keep the phone on as long as the battery has some juice left. Let's break this down line by line to see exactly what's going on under the hood. So here's the play-by-play. First, Python checks the condition. Is battery greater than 0? It starts at 3, so yep, that's true. It runs the code inside and prints the status. Then, and this is the absolute key, it updates the situation with battery equals battery minus 1. The battery level drops. The loop starts over, checks again. Is 2 greater than 0? Yes. This cycle keeps repeating until the battery finally hits 0. At that moment, Python asks, is 0 greater than 0? Nope. The condition is now false, the loop exits, and that final phone shutdown message gets printed. Now, that update step we just talked about, it might seem like a small detail, but it is absolutely everything. Because if you forget it, you've just stumbled into the single biggest danger of working with while loops. Seriously, think about it. What if you just deleted that line? If the battery level never ever changes, it starts at 3 and it just stays at 3. So what happens to our condition while battery greater than 0? Well, it's always true. So what do you think the program is going to do? Yep, you've just created an infinite loop. Your program will get stuck repeating the exact same thing forever. So at its core, an infinite loop is just a loop where the exit condition is never ever met. It's a fundamental bug. Going back to our analogy, it's like a broken smoke detector. It's stuck in its checking for smoke loop, but it will never actually find any. It's just going to keep listening and listening forever, and it will never sound the alarm. That's why that update step is so important. It's the mechanism that makes sure your loop can eventually end. All right, you've seen the theory, you've got the analogy, and you know the biggest pitfall to avoid. Now it's your turn. Let's do a quick little challenge. Okay, take a look at this code. We've got a variable, count, that starts at 0. The loop runs as long as count is less than 2. Inside the loop, it prints loading, and then it adds 1 to the count. So the question is simple. How many times will loading pop up on the screen? The answer is 2 times. If you got that, awesome. That means you're totally getting this. Let's just trace the logic really fast to be sure. The first time through, count is 0, and 0 is less than 2, so it prints. Then, count becomes 1. On the second check, 1 is still less than 2, so it prints again. Then, count becomes 2. Now, when the condition is checked for the third time, is 2 less than 2? No way. That's false. The condition is no longer met, and the loop slams shut. And there you have it. You've officially added a brand new, powerful tool to your coding toolbox. You can automate tasks by a specific count using a for loop, and now you can automate tasks based on a changing condition using a while loop. So start thinking beyond just simple counters. What real-world problems could you solve now? Imagine waiting for a user to type quit, or checking a sensor until a value gets high enough, or just waiting for a file to finish downloading. With while loops, you can write programs that are way more patient, reactive, and honestly, a lot more intelligent. Hey, if this explainer helped you finally master the while loop, let us know by liking and subscribing. It really does help us keep the engine running on more explainers for you.